Hi all, welcome back. So now that we've had a bit of an introduction to polynomials, we've practiced equating coefficients, it's now time we move on to looking at the zeros, the roots and the factors of polynomials, especially those to sort of higher degrees than we're used to dealing with, all right? So if you're following along, Hazy 11 Methods textbook, so this is chapter 4b, all right? So just a few definitions to get us started, because sometimes zeros and roots, those words kind of get thrown and used in place of one another, but they are actually slightly different, all right? So a zero of a polynomial is a value of the variable which makes the polynomial equal to zero, okay? So if alpha here is a zero of the polynomial p of x, when we replace x with alpha, all right, that's what we've done here, our polynomial will equal zero, okay? So a zero is the number that we replace x with that makes our polynomial equal to zero. The roots of an equation are the solutions to the equation, okay? So here we're now looking at when p of x is equal to zero, all right? So when we're looking at zeros, we've just got p of x. When we're looking at roots, we have p of x equals zero. So a root is a solution, all right? So if alpha is a root or a solution of p of x equals zero, then p of alpha equals zero, okay? So they do mean the same thing, but we use them in slightly different contexts. So the roots of our polynomial with variable x equals zero are the zeros of p of x and are the x-intercepts of the graph of y equals p of x. All right, so we will interchange them, but just know that we need to use them in these specific contexts, okay? So if we're talking about a zero, then we're just looking at the polynomial itself. If we're looking at a root, we'll often be looking at p of x equals zero or equals another number, okay? All right, so probably best thing to do is look at an example. All right, so we're going to consider p of x equals 2x cubed, take 4x squared, plus 2x, take 24. If I substitute in x equals 3, we can see that once we start simplifying this right-hand side, that it actually comes out to be equal to 0. So this tells us that 3 is a zero of 2x cubed, take 4x squared, plus 2x, take 24. 3 is a root of our polynomial. I'm not going to keep saying it because it's very long. Our polynomial equal to 0. So see that slight difference there. In our 0, it doesn't have equal to 0. In our root, it does equal 0. And then the graph of y equals our polynomial has an x-intercept of 3. All right, that's just one of its x-intercepts. So that's sort of how you contextualize and pull out the different meanings of zero, roots, and x-intercepts. So x take away alpha is a linear factor of the polynomial p of x, all right? So if our alpha is a root, then we have solved our linear factors of our factorized form of our polynomial. So what we can do, we can actually reverse that process, all right? So if x take away alpha is a linear factor of the polynomial p of x, this means there exists a polynomial q of x, so just another polynomial, different name, such that p of x equals that linear factor, x take away alpha, times by that new polynomial, okay? So it might be a bit hard to see what's going on there, but once we run through an example, then it will be super clear what I mean by that. So p of x equals x take 2 multiplied by 3x plus 1 multiplied by 4x take 2 is factorized into 3 linear factors, okay? So just remember, linear factors are also polynomials, they're just to the degree of 1. So if x take away 2 is our linear factor x take away alpha, all right, then the two remaining terms make up our new polynomial qx, okay? Another example, our polynomial p of x equals x plus 3 multiplied by negative 3x plus 2 all squared. So this is still factorized into three linear factors. One of them is just repeated, okay? So we're going to get a repeated root out of that term. All right, so some example questions of finding all cubic polynomials given its roots, all right? So often or not, you'll be given the zeros or the roots of a polynomial, all right? And when we want to find all cubic polynomials, all right, that means we are going to be finding the general equation of that polynomial, all right? So, for example 1, find all cubic polynomials with zeros, 2, 3, and negative 1. So negative 1 comes from the linear factor x plus 1, all right? So if we're solving that linear factor when it's equal to 0, x will equal negative 1. 2 comes from the linear factor x take away 2, and 3 comes from the linear factor x take away 3. So that means our polynomial p of x equals a. So having this a out the front will give us all cubic polynomials. And then we write in our three linear factor terms. And we always state that a cannot equal 0. If a equals 0, then our whole polynomial will equal 0 as well. So the second example I want to run through, find all cubic polynomials with zeros negative 4 and 2 plus or minus the square root of 3. All right, so we're complicating it a little bit more. So that negative 4, same process as example 1. It comes from the linear factor x plus 4. So with 2 plus or minus root 3, we know that this has come from a quadratic from our quadratic formula. All right, that's how we've gotten that square root. Could have been from completing the square, but more often than not, it would have come from our quadratic formula. So that means these roots have come from a quadratic. All right, so what we're going to need to do, we're going to need to find the sum and the product of our roots and use that to inform what our quadratic looks like, okay? So 2 plus or minus root 3 has the sum 2 plus root 3 plus 2 take away root 3, which equals 4. And the product is equal to 2 plus root 3 in brackets multiplied by 2 take away root 3 in brackets, which if you put into your graphics calculator equals 1. All right, so therefore they come from the quadratic factor x squared plus 4x plus 1. All right, therefore our whole polynomial p of x equals our linear factor multiplied by that quadratic, okay? So x plus 4 multiplied by x squared plus 4x plus 1. All right, and again, there should actually be an a in there. All right, and a cannot equal 0. All right, so hopefully that clears up a few of those questions. All right, please stay tuned for the next video. Thanks, guys.